Ever wondered why the northern and southern lights appear so active right now? Well, let's unravel this cosmic mystery. These dazzling displays of lights are, in fact, a visual symphony orchestrated by solar flares and storms. Imagine our sun, a fiery celestial body, bursting with energy and occasionally ejecting a colossal blob of electrified particles known as a coronal mass ejection. When these particles interact with Earth's magnetic field, they trigger what we call a geomagnetic storm. This storm, in turn, lights up our skies with the spectacular phenomenon we know as the auroras. The frequency of these auroras is directly linked to the solar cycle, a roughly 11-year rhythm of the sun's activity. Currently, we are on a stellar journey towards the solar maximum, the peak of this cycle when the sun is at its most active. So, as we approach the solar maximum in 2025, brace yourself for more delightful light displays. Solar flares and storms are not a new phenomenon. In fact, they have been a part of our universe's narrative since time immemorial. These fiery displays of cosmic energy have been lighting up our skies for as long as the sun has been burning. Our understanding of solar flares and storms has evolved over centuries of observation and scientific research. Ancient civilizations were aware of their existence, but it wasn't until the mid-19th century when English astronomer Richard Carrington first observed and reported a solar flare. This marked the dawn of a new era of solar research. As our understanding grew, so did our need for classification. Scientists devised a system to categorize these solar events according to their intensity. The scale starts from A, being the weakest, and extends all the way to X, the most powerful class. Each category has 9 subdivisions, making an M9 flare just a hair's breadth away from being an X-class event. This system aids scientists in predicting potential impacts on Earth and preparing for them. Solar flares are often accompanied by coronal mass ejections, or CMEs. These are giant clouds of solar plasma that are ejected into space. They are a key player in the solar storms that can impact Earth, causing geomagnetic disturbances and even affecting our technology. The 20th century saw many advancements in solar research, including the discovery of the 11-year solar cycle. This cycle, characterized by periods of increased and decreased solar activity, helps predict when we might see more solar flares and storms. Now, let's fast forward to the present day, where solar activity is creating quite a stir. Just last year, a powerful M9, 6 solar flare erupted from the sun, causing a radio blackout on Earth. It was a spectacle of cosmic proportions, a sunspot 3 times the size of the Earth, bursting with energy and spewing out a solar flare just shy of being classified as an X-flare, the most powerful class. This flare, while a majestic sight to behold, wasn't just a harmless light show. It caused a radio blackout that lasted over 10 minutes across North and South America. Now you might be thinking, a 10-minute blackout doesn't sound too bad? But let's consider the bigger picture. In our hyper-connected world, a mere 10-minute disruption can have significant implications. Imagine the potential impact on air traffic. Aircraft heavily rely on radio communications for safe navigation. A sudden radio blackout, even if temporary, can pose serious safety risks. And it's not just air traffic that's under threat. These solar flares, as part of a larger solar storms, could pose a risk to our global power grids. Yes, you heard that right. Our entire power infrastructure could be vulnerable to these celestial tantrums of our sun. If a powerful enough solar storm were to hit the Earth, it could induce electric currents in power lines, causing widespread power outages. And we're not talking about a few hours in the dark here. The potential fallout could last weeks, or even months, disrupting every aspect of our daily lives, from healthcare and food supply to our financial systems. But don't pack your apocalypse kit just yet. Scientists are keeping a close eye on the sun's activities, studying these solar flares and storms, in an effort to better predict and mitigate their impacts. And while we can't stop these solar events from happening, we can certainly prepare for them and strengthen our systems against potential disruptions. And it's not only about blackouts or air traffic disruption, there's more to the story. So buckle up as we delve deeper into the world of solar flares and storms, their potential impacts, and how we can safeguard our planet against these cosmic phenomena. As the sun grows more active, its effects on Earth become increasingly visible. In a dance of cosmic forces, our sun is entering a period of increased activity, a phase we call the solar maximum. This is part of the sun's natural 11-year cycle, a rhythm that sees the sun fluctuating between periods of relative calm and tumultuous activity. So what does this solar maximum mean for us here on Earth? Well, this heightened activity includes solar flares, coronal mass ejections, or CMEs, and coronal holes, all of which have the potential to significantly impact our planet. Solar flares are powerful bursts of light and radiation that can reach Earth within 8 minutes, the time it takes for light to travel from the sun to our planet. The most potent of these, known as X-flares, can release energy equivalent to 1 billion hydrogen bombs. While this might sound alarming, our planet's magnetic field and atmosphere do a good job of protecting us from this solar radiation. However, they can cause disruptions to our communication systems, leading to radio blackouts like the one caused by an M9.6 solar flare, which was just shy of being classified as an X-flare. Coronal mass ejections, on the other hand, are high-velocity eruptions of plasma from the sun's corona. These CMEs travel much slower than solar flares, taking anywhere from 1 to 3 days to reach Earth. When they do, they can supercharge the solar wind, causing geomagnetic storms that can interfere with our power grids and satellite systems. Then there are coronal holes. These are cooler areas in the sun's corona that allow solar wind to flow out freely. When the solar wind interacts with the Earth's magnetic field, it can enhance the effects of CMEs, leading to more intense geomagnetic storms. These solar events not only have the potential to disrupt our everyday life, but also create some of our planet's most beautiful spectacles. The increase in solar activity and the resulting geomagnetic storms are responsible for the breathtaking displays of auroras, or northern and southern lights, that paint the sky with vibrant hues. So while we marvel at the beauty of auroras, remember, they are a reminder of the sun's immense power. So, what have we learned about solar flares and storms? Well, we've delved into their fiery history, marveled at their recent dramatic displays, and discussed their potential impacts on our planet. These powerful bursts of light and radiation, from the humble A-class to the formidable X-flares, are fascinating phenomena that can paint our skies with breathtaking auroras, while also posing potential risks to our technology and daily life. As the sun moves closer to its maximum in the solar cycle, we've seen an uptick in solar activity. This increased activity can lead to more frequent solar events like flares, coronal mass ejections, and even coronal holes. While these events are a spectacle to behold, they also serve as a stark reminder of the power of our home star and its potential to disrupt our modern world. So, as we continue to witness the solar drama unfold, let's remember to appreciate the beauty, understand the science, and respect the power of these solar events. As we keep our eyes on the skies, remember the sun's activity is a spectacle of nature that deserves our attention and respect.